Today again we are discussing the topic sound. We have discussed that sound and light both are the forms of energy which makes sensation, and in last video we have discussed that sound is produced because of vibrations. What are vibrations? That is rapid to and fro movements of a body about its mean position. In 7th standard you have studied few of the terminologies related with sound. In 8th as well as in 9th standard you will again learn sound in detail, the various phases. So today we are talking the common terms, common concept which explains the mechanism of vibrations, which we are saying as oscillations. Then we will discuss that how sound is propagating, and based on the terminologies related with oscillations we will have the topic characteristics of sound. So let us come to the topic oscillations, and simple definition of oscillations we are having that slower vibrations are oscillations. All of you might have seen the oscillator. Oscillators are nothing but a heavy mass is tied with any string, and that makes our simple oscillators as if you are having any ring and that you are tying with any chain, or if you are having any stone that you are tying with any string, or like this as I am having this iron bow, we can say like that, whatever the heavy mass you are having and that you are tying with any of the string, so this makes our simple oscillator. Now for this oscillator, as very first definition, that heavy mass is tied with any string, elastic string is known as oscillator. Likewise, what is one oscillation? So as you can see over here that this oscillator is doing some movement. This position is known as mean position, and that object, this oscillator, even we are saying this as pendulum also. You might have seen the clocks in which pendulums are there. Then you have seen the child playing in a garden in seesaw. So in that also the child is doing the motion from its mean position. So vibrations are also doing the movement, that is the movement of the particles that we will discuss in the next topic. So the mean position we can say as rest position also, and when we are giving some force, then this object is doing some to and fro motion from its mean position. This is known as oscillatory motion. So vibrations are the examples of oscillatory motions. Then this movement, this motion is taking place at regular interval of time. So it is also known as periodic motion. Now the terms related with oscillation we are discussing one by one. So first, this is the mean position. This is known as displacement from the mean position, the maximum displacement in either of the direction from the mean position is known as its amplitude. So after oscillator and the discussion of the making of the oscillator, we are learning the first important term, that is amplitude. So the maximum displacement in either of the direction from mean position is known as one amplitude. Then comes oscillation. So from any of the maximum displacement, maximum in other direction and coming back makes one oscillation. It means if I am starting from here, then this first position, then maximum in opposite and coming back. This makes one oscillation. We can start from this position. So maximum in one direction, maximum in opposite and again coming back. This makes one oscillation. So in one oscillation, 4 amplitudes are included. It means that this is the rest position, one amplitude, second amplitude, again mean position, rest position, and then third amplitude, then fourth amplitude. These 4 amplitudes makes one oscillation. After that, we are having the symbol of amplitude, that is capital A. Then time taken to complete one oscillation is called its time period. So we can measure the time, that how much time it takes to complete one oscillation. That is the time period, and time symbolized as capital T, and the unit for time is seconds. Now one very important definition term related with sound, that is the frequency of the sound. Based on this, we are going to discuss the characteristics of sound. So frequency, the definition, the number of oscillations in 1 second of the vibrating body is known as its frequency. That means that if I am moving, I am displacing this oscillator in this way, then the time to complete one oscillation, and if I am giving this much force and the object is moving like this, so you can observe that in both of the cases the number of oscillations were different in 1 second. So the relation between time period and frequency we can give by this. Frequency is denoted by Greek alphabet nu, and for simplification we are writing as F also. The relation between frequency and time period is inverse. That means if the frequency is more, if this many frequencies are there, then time to complete one oscillation, this pendulum will go like this, then the oscillations will be more. So frequency will be more, but time to complete one oscillation will be less. And compared to that, if the time to complete one oscillation is more, then the number of frequencies in 1 second will be less. So we are getting this important relationship between the frequency and time period, that is F equals to 1 upon T. For example, if I am saying that time to complete one oscillation is 0.02 second, so I am having this formula. I can substitute the values f equals to 1 upon 0.02, which gives me the answer as 50 Hertz. It means if one oscillation is completed in 0.02 seconds, then in 1 second that oscillator, that pendulum can oscillate 50 times. Now let us understand the second topic, propagation of sound. Propagation means to travel. We have discussed that sound needs a material medium for its propagation, for traveling. So, very first, the matter through which sound is transmitted is called the medium. We are having three types of medium: solid, liquid and gas. Out of this medium, what happens actually, that whenever we are having any vibrating body, it is in any of the medium, solid, liquid or gas, it is vibrating. So we have written over here that it sets the neighboring particles of the medium sets to vibrate. These particles do not travel in the medium, but they are just vibrating. It means they are just displacing from its mean position and coming back to its original position. Then this displacement is passed to the next particle of the medium, and that particle is displaced. Then it comes to its position, and that displaced particle is setting the next particle of the medium displacing. Like this, we have written that the sound is traveling from the source of origin to the listener through the medium. This we can understand with the help of the slinky also, which is a very long spring. Say just now, these rings are the particles of the medium which are at rest position, at equilibrium position or at mean position. Now from any of the side, some sound, some vibration is coming. Say from this side. So this particle which is in contact to that vibrating body will come in the motion and it will displace. That displacement will be given to the next particle, then it will be given to the next until we are listening, that means with our ears. So the whole process, you can see that somewhere in between the position, the parts of the higher density of the closed spring has been created. So that we can denote it by this graph, this diagram, that say this is the speaker. Then this is the rest position of the medium, that might be solid, liquid. Here we had tried to draw the gaseous medium as we are speaking and it travels through air. So this is the equilibrium position. As vibration comes, these particles are displaced and they are gathered over here. Then they come into their original position and they displaces the next particles. So we are having some regions which are having this kind of gaps. Somewhere density is very low of the particles of the medium and somewhere the density is very high. The regions of the high density is known as compressions and the region of the low density is known as the rarefaction. So we can say that sound is passing by successive compressions and rarefactions through the medium. This density can be represented graphically in this form, which we are saying as sound wave.
आभार।